Hey everyone, this is Don from Loqheart. In this video, I want to show you how you can use the latest version of Spriteloq in order to create shapes for your sprites so you can get them into your Corona apps and apply physics to them. You can find out more about this feature on our new Spriteloq subforum on the Corona forums, and you can also head over to our website and check out our video and docs section for information on the API in the API library docs. You can head over to the Loq Sprite module, and there's an example in here adding physics properties with the add physics method that we've added to Sprite group instance. And here you can find a little bit of sample code that walks you through how to get physics for your sprites into your Corona app really fast. But in this video, I'm going to show you a sample app that I put together, and I'm going to show you how to get your shapes out of Flash into Spriteloq, get some collision boundaries on them, and create a simple application. So the first thing is I created a whole bunch of different shapes here. You can see I have a box, circle, a long rectangle, I'm calling it a plank, star, a red triangle, and a purple triangle. And if you look carefully, the reference points or the registration points for each of these objects is a little bit different. And this is going to be really important when we bring these into Spriteloq to create shapes for them, because you'll see how they will eventually affect the position of the object in the application. So as always, first thing you want to do is you want to go to commands and export your library as Swifts, and then we'll get all of these into Spriteloq. So I'm going to load up, let's see, all of our shapes here, and I'm going to walk you through the new tools that we have for drawing shapes. So I want to draw a box for this box, and we access the shape tools by dragging down the controls panel here. And notice we have a new shape controls section, and this first tool basically switches us into shape mode, where we can draw shapes and view the shapes on our sprites. So first thing you always want to do is click on that, and then in this case I want to draw a box polygon for this box shape. So I just click there, and notice my cursor changed, and I'm going to draw a box over my box and let go. And there I have my box. Notice that the delete icon here lights up, so you can remove that, and I'll go ahead and do that and draw it one more time. Okay, and so we have our box. And now for our circle, I'm going to enter shape mode again, click on the circle polygon tool, and try to center this, and then click and drag to create a circle that matches. And what you notice over here is that in Corona, when you create a circle, it's centered around your reference point. And sometimes that's not useful. Sometimes you actually want to have your circle off-centered. In this case, our reference point is in the upper left corner over here. And so what Spriteloq does is when it creates a circle, it actually generates a polygon. So all these circles that you see around here are actually anchor points for a polygon. And when this gets exported, it actually gets triangulated, and this will be explained more clearly when we see the application. But basically, all these points give us a circle. For this plank, I'm not actually going to create a physics body for it. What I want to show is that if you don't draw anything on a rectangular, or if you don't draw anything on your sprite, I'll end up using this bounds rectangle to create a physics body for it, a collision body for it. And so I'm going to leave it as is and go to the star. And with the star, I'm going to draw our polygon with the polygon tool. And with this tool, you can create a convex or concave polygon. And in this case, the star is a concave polygon. So I'm going to really quickly just click on the vertices. And notice how with 3 clicks, a triangle formed. With a 4th click, now we have this self-intersecting polygon. And I'm going to continue to click until we get our star. Okay, and so there I have my star, but it's not quite finished yet. The thing about the polygon tool is that in order to close off your polygon, you have to click on the Create Polygon tool again. And then you see the delete button light up. So that means that the shape has been saved. Notice that this tool also has the circles like the circle tool did. And that means that you can actually click and drag these anchors. And you can adjust the position of the vertices of this polygon. And you might have noticed that these anchors didn't appear on the box tool because the box tool is kind of a special case. If you need to resize the box, the only way to do that right now is to delete the box and redraw it. So there we have our star. And next thing I want to do is take a look at this purple triangle. But what I'm going to do here is I'm actually going to skip drawing a shape for the purple triangle, and I'm just going to do it for the next one, the red one. And I'll show you an interesting thing about this. Later on, I'm going to use the collision shape of this red triangle for the purple triangle. So this will be an example of how you can basically use one shape and apply it to a lot of different sprites. So 3 clicks and I have my triangle. And click there and I save it, but I'll just do a little quick adjustment here. Okay, and I think that'll be pretty good. Now I can just right click and select everything in the asset list and pack it. And now I'm going to export my sheet into my project folder and save it. Okay, so I'm going to show you the project now. So there you go. That was really quick. You can see we have a bunch of physics going on. The circle is kind of rolling around like a circle. The triangle is triangle, but this purple triangle is a little weird. The star kind of bounced off stage really quick. I'm going to reposition things a little bit, adjust some of the physics so you can get a better look at what is going on. Oops. So I'm going to just set the scale to 60 to slow things down a little bit. And maybe I'll adjust it to 80. Okay, there you go. And let's see, with the star, I'm going to lower it a little. See what that does. Okay, so you can see that a little bit better. Alright, so what I'm going to do now is I'm going to switch from the normal drawing mode to hybrid mode so you can see the polygons that were created. Okay, so basically all the shapes are as you would expect. Notice that the plank also has a physics body, and the triangle does as well, even though we didn't specify them. And I'm just going to walk you through some of the code here real quick for this project. So the first thing is just draw a blue background, and then I'm going to require the physics module, start it up, set up its gravity here, and here I just set the scale, and I'm drawing it as a hybrid. And then here I'm loading up Loqsprite, but I'm not saving the module. I'm just going to create a factory out of it and load in the Spritesheet, and I'm going to call that Sprite Factory SF for short. Then I create a whole bunch of physics bodies here. But the first thing I do is I create a sprite for a circle, and once I have that circle, I can call add physics, and I pass in the physics module, the type of physics body it is, it's dynamic, and then its properties, density, friction, bounce. And basically the Spritesheet that we loaded up contains the shape data for the circle. And so when I call add physics, it automatically looks that up and applies it to this sprite group. And here I do some positioning, and I do the same thing for the triangle, the purple triangle, the box, and the star, and the plank. And so with the interesting thing here is that for the purple triangle, it's actually a kinematic body, meaning that it's not affected by gravity, or and it's not like going to be its velocity is not going to be affected when something collides with it. But the physics body, it looks kind of weird, right? It matches the frame of the sprite, and that's not exactly what we want. We want it to behave like a triangle. But remember, back in Spriteloq, we never specified a physics body for it here. We did it for the red triangle, but not the purple one. So what I'm going to show you is a way to reuse a physics body. We're going to pass in another parameter here at the end of this purple triangle add physics call, add a comma, and then I want to I want to give it the triangle's physics body. So I'm basically taking the red triangle's physics body that we specified here, and I'm going to apply it to the purple triangle. So I'm going to save that, and back in our application, notice that the red triangle slid off because this purple triangle now has a proper physics body applied to it. And the last thing to note is for this plank, it also had no physics body, but it ended up getting a rectangular body. And the interesting thing to note about that is if you try to add if you do this add physics call and you don't specify anything, then it'll automatically have the bounds rectangle shape applied to the sprite for its physics body. And the last thing I have in this demo is that since this purple triangle is a kinematic body, I added a touch event handler to it here on touch. So you can drag around and see how this triangle will affect the other physics bodies. One thing to note is that since the circle is a really complex, it's basically a combination of a lot of triangles, as you can see in this hybrid mode. If you get other really complicated bodies colliding with other complicated bodies or complex bodies, you might end up getting objects stuck inside of each other, and that's really a side effect of Box 2D. So you should just be careful with complex objects in general. Try to keep your objects simple if you can. The last thing I want to talk about is the profiler you see up here. You've probably seen this in source code, but I just wanted to give it a quick mention. Basically, you can instantiate that here at the bottom, calling lock profiler, and then, or requiring a lock profiler, and then calling create profiler. And what it does is it gives you a frames per second graph as well as a application memory usage graph. Here you can see the memory and texture memory for any sprite sheets that you've loaded, the instant frames per second as well as the average frames per second, and you can see the min and max for these values here. So there you go. There's an example of physics done really quickly using Spriteloq, and yeah, I mean, with the circle stuff, it works, even though the reference point is off center. So I hope you enjoyed this feature. Let me know what you think of it on the forums, and please check out our Twitter feed as well. And thanks for watching.